Yeah, Neil Chilton, Printed Electronics
Very good.
Limited, already on stage. And yeah, Neil, feel free
I
to
am to share
start.
the screen
Yeah,
if it lets
exactly.
me. There you go. Let's see. Let's look at that.
Don't give me a
So
heart attack.
I'll try not to. I'll try not to. Hey,
Neil,
that almost works. There you go. Is that okay?
perfect. Perfect.
Good.
Neil, the stage is yours.
Thank you very much, and thanks, Christoph, thanks, Kasia, and everybody for organising such an excellent arrangement for this day. My name is Neil Chilton. I'm the technical director and one of the founders here at Printed Electronics Limited. And today I'm going to give probably the longest titled presentation, but hopefully by the end of it you'll understand why I give it such a long and not very friendly title. But let me explain a little bit about Printed Electronics as a company. So that's our focus. So day in, day out, we make parts for customers. We focus on production scale up and process and product development. We've been operating since 2006, so we've got a long history. We were lucky to be fairly first in the queue. We got the domain name printedelectronics.com many years ago, so we're lucky we don't have to pay Google very much to be top of the list in printed electronics searches, which is nice. We very much have a European focus, and we're actually based inside the UK's largest printed circuit board company. So we have a very close link to conventional electronics manufacturing as well. And we have a very well-equipped facility in the UK, which you're very welcome to come and join. So our focus is manufacturing, number one, as I've said. The other focus area is selling equipment and materials. Some materials that we make ourselves, and some equipment we make ourselves, but also best-in-class equipment for screen printing, inkjet printing, nozzle deposition, that kind of thing, which I'll explain later. And of course, we, like all of us, I think, in this room, we also focus on process and product development and R&D, because that's a key part of printable electronics still. So what we show here on this slide is that we do manufacturing, do process and product development. We also work in various areas like 3D and conformal printed circuitry, as well as fabric and wearables. I'm not going to cover those very much today. We have expertise in electronics design within our team. So we do the printed side and we do the electronic side, which obviously works quite well together. And these are some of the machines along the bottom which we sell and support. And most importantly, these are the machines that in almost all cases we use. So we're not just a consultant for this, we actually use these bits of equipment. So printable electronics, printing as a whole, what is it? Well, your first thing to remember, we all have to remember this day in, day out, is that we are choosing to, unlike PCB guys, unlike silicon guys, we're choosing to manufacture with liquids, which may or may not be an easy decision to make. So we have an inkjet head here, for example, showing a lovely deposition of drops onto a surface. But then the drop hits the surface, it perhaps spreads because it's a non-absorbent surface, and then you've got something like the Marangoni effect. So we have to remember that printing with printed electronics, or printing generally, for us in printable electronics, is not the same as what everybody day in, day out thinks of as printing. So if you ask the average person, is printing easy? Is using the inkjet printer on your desk, is it easy? Yeah, it is. It's really easy because it relies on decades of research and development behind it. But most importantly, the reason it's easy is because we mostly deal with absorbent substrates in the case of printing, right? Whether that's graphics printing or even some printed electronics, as we're showing here. So if you have an absorbent substrate, you potentially have an advantage because your low viscosity solvents from your inkjet process can be absorbed into your base substrate, leaving the good stuff behind on the surface, which is what we're showing here. I'm not going to go into the detail of that. But in printable electronics, we don't have that luxury so often. We've been involved in inkjet printing since 2006, since we started, and this is some results shown, just as an example, showing what can happen if you're printing onto a non-absorbent substrate, as many of us are, and you don't have the process optimized, right? So these are all the various considerations that you need to have in terms of printable electronics. And of course, what I've shown in those two images there is inkjet fluid, which when jetted down onto a surface, whether it's an absorbing surface or a non-absorbing one, the important thing to remember is that a lot of that fluid is the solvent that allows that fluid to be the low viscosity that it needs to be able to be inkjet printed. And in the case of inkjet, we have to either absorb or evaporate off an awful lot of that height of fluid in order to leave behind the good bit, the bit that you need. Whereas with a screen print fluid, it's necessarily higher in solid content, and therefore the relationship between the amount you deposit and the amount you actually get left with is very, very different. So, this is one of the main challenges with choosing your process for printable electronics, is understanding the total picture the substrate is and what your post processors need to be to leave behind the material which is important to you, because most of the time we're looking for solids and we're printing liquids. So which print method should we use? This is a slide similar to many of the others you may see today and have seen already. I have highlighted in red, highlighting here some of the processors that we sell and support. We don't do anything here at Printed Electronics which is roll to roll. Everything we do is flatbed. So I'm focusing on the ones which are generally suitable for flatbed or single piece part. As you can see, in terms of the length scales involved in printing or manufacturing in general, we have different processors which fit different niches better than others. If we look at semiconductor processing, there's very, very, very few processors in printing that can get close to semiconductor scales. And of course, none of us can get into the nanometer range. I'm talking about the micron range. So we've got aerosol, we've got XTPL that I spoke earlier on today, which I should include in my slide. Sorry, Lucas and the team. And we have other processes as well. And of course, gravure, as NSM have also mentioned earlier on, works extremely well at very, very low scales. But inkjet, for example, inkjet is pretty well limited to 100 micron, 50 micron perhaps, so it's got its own place. Aerosol fills other gaps. So in order to choose which method you're going to need to use, you have to decide what ink and what design you're going to print. Then you have to decide, is every print that you want to print identical every time? If it is, why choose a digital process? Okay, there may be advantages to that, but if it could be that gravure, flexo, screen printing is the right choice for you. What is the substrate? Is it flat? If it's not flat, then inkjet could be a very, very good process, as already described today in the inkjet printing of flexible and stretchable materials onto sticky tape. Very, very good example of why you'd use inkjet there. And then you have to incorporate all of these other questions as well. But from my point of view, and this is partly a joke, but the first three questions that when somebody asks me which process should I use for printed electronics, the first three questions are this: can I use screen printing? The reason I say that is because we can use viscous pastes, which give us thick paste deposits. We can also get very fine lines down to 15 microns, say. So that should be your first question. Your second question is, are you sure I can't use screen printing? And your third question, are you really sure? That's partly a joke, of course, and every process has its own benefits. But the reason we in our own manufacturing, day in, day out, use our screen printing equipment, and by the way, we represent Microtech in the EU. This is the type of machine that we use here. The reason we use it every day is quick turnaround production of potentially very fine line equipment, very fine line devices for predominantly medical security interface and sensing applications, because those are the primary applications which we in Printed Electronics Limited support. So every day we're making products with our screen print machines, and we're using inks that are well understood. We're using processes which are well understood. These are the type of machines that some of them we have, and some of them we sell and support. There are a number of these in facilities in and around the UK and Europe. So you may come across these in your own work. And if you're interested in these machines, please do get in contact. And one of the things that we as a company have done over many years is to become well well known in applications where we make demonstrator products for our customers. And this is one that we made for Panasonic for their new BLX material a number of, well, maybe a year ago or so, which is an NFC demonstrator. So we made these as demonstrator products. This is a very, very interesting substrate, which you can check out from Panasonic. The silver ink is a stretchable ink from Asahi Kagaku, who we support, and it provides for a very interesting demonstrator. And why is that one made with screen printing? Well, because the material needed to be quite thick in order to allow the stretching. So those are the advantages of screen printing. But there are many cases where digital printing is essential. Your substrate may not be flat. You may have a different design every single time. You may need to account for scaling of processes. If your first printing process and your curing process stretches or shrinks the part, then coping with scaling for subsequent layers, inkjet printing is absolutely superb for that. And we work closely with the guys in SUS Microtech and Fujifilm Dymatics for research scale. And another very extreme example here is something we did back in 2012, where we used an inkjet printing head to show the real extremities of non-contact printing onto an aerospace helmet, of printing a silver ink, which was subsequently electroless plated. So silver was the catalyst for an electroless copper process. This is extreme. This is not a realistic production approach, but it shows that you really couldn't do that with other processes. So non-contact printing is extremely important. But that ink, which is going down, is a very low viscosity ink. 95% of the drop has to be evaporated off, leaving 5% by weight as your good stuff, your silver. But inkjet is important to us, and we work with a number of partners. One of the partners we work with is Integrity in the US, who make production scale machines for pharmaceutical applications, for bespoke medicines. This is one of those, and powder bed applications too. But of course, your main applications for inkjet, as you well know, very high speed, variable data stuff, things that can go at this type of speed, as you can see. So inkjet absolutely has its place in printed electronics, but it has to be used at in the right time and place. And one of those disadvantages to inkjet is that you need to use a low viscosity ink, but sometimes you might actually want to use a high viscosity ink, but you need a digital print process. And here's an example of a machine which we make, which is called the 3D SP platform. And this is showing here that we're jetting a screen print ink. So this is an ink from Dikatech, which is a nanoparticle silver ink, which screen prints very well, but it also jets very well from our piezo jetting head here. So we make this platform, we use it for our own work, and we've sold a few of them in the UK. And this is a 4-axis platform, really, X, Y, Z, and theta. But that same print process, and by the way, this is what you've seen what inkjet looks like. These are those jetted drops from piezo jetting. This is our drop watching platform, which we build and sell. So this allows you to see the drop in flight. So it's not as clean as inkjet drops for sure, because it's a viscous ink. But those same heads can then be used on a much more advanced system. This is the Neotech AMT platform, which I'm sure you've all seen before. This is the pretty famous by now example from Martin and the team of printing using fused deposition, coupled with printing with piezo jet, which is the example here, coupled with pick and place, coupled with many other things. And we've learned now that we don't try and do everything ourselves. We work with very good partners, and the partner that we work with in 5-axis deposition is AMT Neotech, and you'll have seen this in other presentations, I'm sure. A very capable system. But what if you need smaller features? Smaller than inkjet can do, smaller than piezo jetting and screen printing can do. How about things which fit between this semiconductor process area and chip scale packaging, for example? This is where you're looking for things which can print in the tens of micron or single micron positions. So here we're talking about superfine inkjet and aerosol. In the case of aerosol jetting, we work very closely with IDS Nanojet, and this is the system which you will also be able to see from the guys in IDS who have their stand here as well, I think, showing printing of something like a 10 to a 30 micron line, and this is the IDS platform that we sell and support. A very, very well established company with very good knowledge of aerosol jetting. And then if you want something even smaller than IDS can achieve, then we have the superfine inkjet system, which we've already seen already. A very nice presentation from Murata-san earlier today. And what I would like to do is just a very brief shout out to the guys at Glasgow University from the BEST group, who have created a very, very nice demonstrator using the SIJ system. This is a energy harvesting platform where the SIJ is used for printing vertical 5-micron pillars, which are then sintered into this form here. And subsequently from sintering, they also managed to create AI, which is very cool. Then subsequently from sintering, they decorate these with zinc oxide nanowires and create a very interesting demonstrator of energy harvesting. And you can see the tree trunk down here was printed with SIJ. So the reason I'm showing this is because it's a very nice, very cool picture. I don't profess to know enough about this to answer any questions on this. So please contact the team, Shihang Ma and the team up at Glasgow University to ask more about that. And then one of the questions we get asked many, many, many times is, okay, so you've shown that you can demonstrate this with single nozzle and everything is easy to show, just making one-offs. But how about scale up? Well, I stole this slide here from the presentation earlier today with Murata-san. This is actually the first time that the multi-nozzle head has been demonstrated or explained outside of Japan, I think. A very nice example of scaling up a single nozzle process to a extremely high number of nozzles for parallel processing. So I must be doing okay for time, maybe. I don't know. I never am, so I'd be surprised if I am. But anyway, this is a little bit about printed electronics. Please go and look at our website. Please come and talk to us in the break after. We're a manufacturing company. We know about equipment and materials, and we're very interested in process and product development with partnerships. So that should be me done. Thank you very much, Christoph, for not interrupting me. Thank you. Brilliant.
Well, I won't allow questions now, unfortunately.
No, I wouldn't do it if I was you. Yeah.